Well, in our work with lines, we've come across lines that are going across the number plane at all different types of angles. Some of them are totally horizontal, and some of them are running lovely and diagonally, obliquely across the number plane. Some of them are almost vertical, and others are almost horizontal. So we want to quantify in some way. We want to give a number to describe just how steep the lines are. And gradient is a word we use to describe how steep something is or the slope that something has. The gradient of a mountain, the gradient of a ski slope will tell you how steep it is. Now, gradient on the number plane is measured in units up per 1 unit across. Now, we might use a number of units up compared to a number of units across in order to calculate that. But in the end, we say, how many units do you go up or down for every unit you go across 1 to the left? That tells you how steep it is. So the gradient is the rise, the vertical change, divided by the run, the horizontal change. And it's like a rate. How many vertical units per 1 unit across? We always move from left to right when we describe the gradient on the number plane. That's because, well, in the English-speaking world, we read from left to right. We read from left to right. We walk from left to right, if you like, across the number plane. And if we're walking from left to right across the number plane and we end up walking uphill, that's a positive gradient. If we walk from left to right across the number plane and we end up walking downhill, that will be a negative gradient. It's like we're going up negatively for every 1 unit we walk across. Let's have a look at some examples. This first example here, I've got a couple of points drawn up on the number plane. Let's come in a bit closer there so you can see it more easily. We've got the point 1, 2 and the point 4, 5. And we've been asked to find the gradient of the interval that joins them. Find the gradient of the interval that joins those 2 points, or find the gradient of the line that goes through both those 2 points. So, just get a blue pen here. We've been asked to find the gradient of that interval there. How steep is it? How steep is it? Well, how many units does it go up for every 1 unit across? Sometimes that's hard to find out. Sometimes it's straightforward. In this case, it's very easy to find out. For every 1 unit across, all right, that's 1 unit across, and we always walk that way from left to right. For every 1 unit across, we end up going up 1 unit to get back to the line or the interval, right? For every 1 across, we go up 1. So it rises 1 unit for every 1 unit of horizontal run. The rise over the run is 1 over 1. So the gradient of that would be 1, which basically means it's diagonally across the number plane. Like another way to work it out, if we didn't want to draw up that triangle, is to pick any suitable triangle from the information given. Now, I can see a suitable triangle here would be this one from the 2 points that are actually given. There's a suitable triangle on the number plane. Now, we can say that in order to walk across this far, how far did we have to go up? What was the rise, the vertical rise, when we walked across that much run? The rise over the run gives us the gradient. So how much did it go up for this much across? Well, to figure out what that length is there, as we did before when we did the distance formula, we would say the vertical height of this is 5 and the vertical height of this is 2. So this must be 3. all the way up is 5, but take off the 2 and you're left with 3. To figure out the horizontalness that happened when we went from this point to this point, we need to know that, just like when we did the distance formula, we say if we're all the way across here, that would be 4, and if we're just that far across, that would be 1. So 4, but take off that 1, leaves us with 3. So you can see that I'm subtracting the y parts to find the rise, and I'm subtracting the x parts to find the run. I mean, I can just look at it if it's on a grid with squares and count up 1, 2, 3, and here I can count up 1, 2, 3. So it's going up 3 and for every across 3 that I do. It's going up 3 for every 3 that I walk across to the left, because I walk from left to right across the number plane. 3 divided by 3 is equal to 1. Okay. Another way people might write it is they might say that the gradient m is equal to the rise over the run, and that's equal to 3 divided by 3, which is 1. The gradient of that interval is 1. Now, the letter we use to describe gradient often is m, and I think that comes from a French or Latin or word from Europe meaning mountain, mons, mountain, mons. So gradient, steepness, mountains. So we're using the letter M to describe gradient. We're walking up the mountain. Let's have a look at just a couple more examples, 3 more examples. I'm going to speed it up a little bit now. The next example, I can see already that the gradient of the interval joining those 2 points will be negative. Why? Because as I walk from left to right, I'm going downhill. I'm going downhill, which means it'll be a negative gradient. That's the first thing. Now, let's have a look. We've got how much rise? Well, line that up. There's the triangle I might draw in for it. And the rise is that distance there. This point is up at 4. This point's up at 1, so that's 1 in there. So 4 is all the way up, minus off the 1, it gives me 3 there. 4 minus 1 equals 3. The rise is 3 between those 2 points. The run over here, this one's out that way at 1, and this one here is out this way at minus 2. You can see that at 1, 2, 3, that's 3. That's what I should get. But if I subtract 1 minus 2, I also get 1 plus 2, which is 3. So if I subtract the y parts, the second numbers in each pair, I get the rise. And if I subtract the first numbers in each pair, the x parts, I get the run. I need to make sure I do things in the same order. It can be best to just do the most right-hand one first and the most left-hand one second. But if you didn't have a diagram of it, it's okay. Just make sure you stay with the same point to be the first one you lead off with your y and your x. I'll show you what I mean. The gradient equals the rise over the run. And in this case, it's equal to, and we said we would start with this one here, if you want, and you can do 1 minus 4. And because I started with this point, for the y's, I did 1 minus 4. I've got to start with this point for the x's. 1 minus 2. So that's negative 3 on 3, which is negative 1. Now hold on a minute. Didn't I write down 3 there? Yeah, but if you want to do it just by looking at the diagram, you say it's negative. It's negative. 3 divided by 3 is 1, so it's negative 3. Or you can say for each 3 across, I went down 3. So it's got to be negative 1. It's down 3, negative 3 for each 3 across. But if you're using just the numbers, you make sure you go in the right order. If I decided to do this in a different order, and instead of doing this 1 minus 4 divided by 1 minus 2, I decided to do 4 first minus 1, then I've got to do the x's the same way. Minus 2 minus 1. So that will be 3 over minus 3, which is still minus 1. So as long as you do consistency, you'll get there. Now, if you look at what it's saying for each one that you go across, the graph has gone down 1. You go down 1 for each one across to the left. That's what it's meaning. It has a gradient of minus 1 because it goes down 1 for each one across. 2 more quick examples. This next example here, we want to find the gradient of this interval. I can see straight away that it's positive. I'm really not sure. Maybe it goes through there. I don't know. No, that's pretty poor effort. Oh, I can't see where it goes, so I'm going to have to work it out. The gradient is definitely positive. We've got to do the rise over the run. M equals rise over the run. So the rise, how about we use this first? So 4 minus 2, and then this second, 2 minus 1. 6 on 3 is 2. It's going up 2. So for each one across, it goes up 2. So it should have gone through the origin there, because 1 across and up 2, right? And 1 across and up 2, and 1 across and up 2. So I guess it's just because it's not drawn on a proper grid that it's looking a bit off. But it should have gone through the origin. But just to let you know, I would get the same answer if I did minus 2 minus 4 over minus 1 minus 2. If I started with this point, I've just got to be consistent. That would be minus 6 on minus 3, which does still equal 2. The gradient is 2. For every one you go across, you go up 2. You're back on the line. For every one you go across, the line goes up 2. Okay, last question. Clearly another positive gradient because you're going uphill as you're walking across the number plane. Hard for me to see where to draw this through, so instead of drawing the interval in straight away, we're finding the gradient. I'm just going to do rise over run and find out for every one across how much it goes up. So M equals rise over run. The steepness or gradient is rise over run. The rise is 2 minus 1 over 3 minus 3. Okay, that's 2 plus 1. That's 3 over 6. That's a half. What does it mean? Well, a few things. You interpret it in a number of different ways. You can say it means that for every 1 unit you go across to the left, you go up half a unit. So it's not particularly steep, I guess, compared to some of these other ones we've done. For every 1 step across, it's only half a step up. because the gradient's normally telling you how much up happened for one across, and it's always to the left. That's why it's positive here. So for every one, you go up half. Well, that's not going to be too helpful for me joining all these up carefully, is it? But for every one across, I only go up a half. Across one, up a half, it would be there. If I go across another one and up another half, I'd be there. So that's one way to look at it. Of course, you can always look at it for what it says. It says up on across, rise on run. So it says 1 up for 2 across. 1 up for 2 across. So I could have just said, if I go across 2, I'm going up 1. I still land in the same place. So it's got a gradient of a half, and it went through there. It goes across 2 and up 1. It goes across 2 and up 1. So that's the interval there if I joined it up. Gradient is rise over run. It's the difference in the x values on the bottom and the difference in the y values on the top. I'm going to write that down here. The gradient is equal to y2 minus y1 on x2 minus x1. The difference in the y values on the difference in the x values. So if you had 2 points, you wanted to find the gradient of the interval that joins them, and this point was x2, y2, and this point was x1, y1, then you would just do y2 minus y1 on x2 minus x1. That's what we're saying. So you wouldn't even need to draw it up. You could work it out. And you wouldn't even need to know which one was on the right-hand side of the other, because, as we've discussed, you could do y1 minus y2 on x1 minus x2 and get the same result. But you've got to be consistent as to which point you use first each time.